So my name is Alex Alcoccer. So I'm a professor in robotics at Oslo Metropolitan University in Oslo. And I will gonna talk a little bit about one of the technologies of the ANERIS project, which is called EMUAS. So here, yeah. So this is the laboratory where I work. It's called OsloMet Ocean Lab, and we have a lab which is only a few meters from the Oslo Fjord, from the water, which is very nice for being able to test new technologies very fast from the laboratory to the sea. And we have been using this extensively during the ANERIS project. So first, all of you saw the presentation, the first presentation by Jaume, the project coordinator. So I just wanted to just see how my presentation will fits in all these on the ANERIS project. So as you have seen, one of the main ideas of the ANERIS project is the concept of operational marine biology data products. So how do we go from the acquisition of observations in a most automatic manner as possible to the generation of valuable information on marine biology? And the technology I'm going to talk about is specific of the imaging technologies. So that's where the EMUAS fits on. So getting images from the underwater, it's quite of a expensive and complex endeavor. One of the ways is by having subsea observatories that need to have a cable to the surface, and depending on where these observatories are placed, the costs of installing and maintaining these observatories can really expensive, which makes that actually there are very much. I think it can be counted with the hands of with one hand how many of these observatories exist at the moment, providing real-time imaging from subsea locations. So in the ANERIS project, we tried to approach this challenge of the lack of this imaging information by developing a low-cost version, which is called the EMUA system. And one of the possibilities of use of the EMUAs is to extend existing observatories. So you have a cabled observatory in a location which has already some instruments. So through the ANERIS project, we develop a technology that can extend the existing set of sensors by providing multiple cameras with a relatively low cost. And the MOA system can also be used in a standalone configuration. So that's having a camera, then a cable to the surface in a place where we can provide power from the power outlet and provide Wi-Fi connectivity, or even a totally self-contained solution, which has solar panels, batteries, and provides 4G mobile connectivity on its own. And the idea of these systems is to scale, to increase the amount of observations that can be done in an automatic manner from fixed locations. So this is one example of what one of the partners in the ANERIS project, UPC, have been doing with one of the observatories called OPSI. So this is an observatory. It's a little bit south of Barcelona. It's around 20 meters deep. And they have been trying some of the automatic AI-based fish identification algorithms. And this is part of what we are trying to improve and operationalize during the ANERIS project. Now, what are some of the challenges when you are having some cameras for a long time deployed in underwater? One of the main challenges is biofouling. Anything that you put underwater, it will start growing some organic material. And the severity of it depends on the amount of light, the temperature of the water, the depth. There's different factors, but in some places, in a couple of weeks, your sensors will be totally unusable. So in the ANERIS project, we try to develop some smart solutions for this problem. The commercial available solutions for biofouling mitigation for cameras are basically wiper that's mechanical, like let's say a brush mechanism, which regularly just brushes and tries to remove mechanically these growth particles from the lens. Or there are also ultraviolet based systems. What they do is they emit a certain light in a spectrum that is damaging for cells. So it actually kills the growth of the so avoids the growth of this organic matter. But these systems are relatively expensive, complex. So we tried to do some improvements in the ANERIS project. The technology that we're developing is open source. So we are publishing all the developments. We have a GitHub repository, and we try to use as much as possible commercial off-the-shelf components like Raspberry Pis, Blue Robotics components to make the replication of these systems as simple as possible. One of the first prototypes that we developed was a mechanical wiper concept that used magnets for the transmission of the movement. So to avoid having moving parts exposed to seawater and to simplify the cost and the manufacturing. So this is the pictures of some of this first prototype. It was assembled with lights and an hydrophone. And this we tested for, I think, around maybe 2 months in Oslofjord. And here are some pictures on during the night when the lights were turned on. And a short video I show you about this first prototype that you can see some more results. So as you see, it's quite prototypish result. This is a wiper that regularly will be operated to keep the dome clean. And this is in testing in a small water tank that we have at Ocean Lab in OsloMet. And these are images taken with a small ROV of the deployment that we did in Oslofjord. And as you will see later on, at this stage, we had a very bad camera. So the resulting images were not very good. I think you can see here. Yeah. So we did live stream into YouTube for some period of time. And so these are the sort of images that were generated. And at night, you can see also when we're turning on the lights, it actually affects a lot. So we attract small fish that probably will not be there otherwise. But it's So this was the first prototype, and after that, we have been doing quite a lot of improvements. One of the first improvements that we did is to replace this mechanical wiper by an ultraviolet system that had also a relatively low cost, but this ultraviolet system was placed outside of the camera. So here you can see maybe some detail. This is where this ultraviolet diode is, and it's pointing towards the flat glass of the camera. And these are results of 3 weeks of deployment. So the results were at first satisfactory, but we were still not very happy with the fact of having added penetrators for these ultraviolet components. It's a little bit complex overall. So we still wanted to make it even simpler, the system. We have been involved in several public outreach activities. This is one example of a festival that it happens every year in Oslo, where at least like 100 or 200 families came to our lab, and we were showing the live streaming on these images as part of the activities. We also participated in a hackathon together with another European project called Iliad. And we used the live streaming of the ANERIS MUAS cameras with a group of participants that were developing artificial intelligence algorithms for automatic detection of species in the Oslofjord.
Working on different solutions to monitor the fjord.
And this is some of the video streams that we generated during that hackathon. You can see this is just in front of our laboratory. Unfortunately, Oslo Fjord is not really rich in terms of the quantity of fish, but there are some very small ones. And yeah, so this is another video, I think, show. In this one, I think you can see a small cod. This is one of the fish that is actually disappearing from Oslo Fjord, which is very sad. It used to have a very important economical and biological value, but they're less and less every day. And this is one of the technologies that could use to actually provide continuous measurements on the on this type of on the abundance of this fish. So another of the deployments that we did, it was about 150 meters from our laboratory. So it was a little bit too long for us to have a cable. So we had in this case we tested the standalone configuration where we have a Pelican box that you can see here that contains a 4G router. So it provides internet connectivity to the camera, and we connect it to a power outlet in the harbor actually. So we deployed this about 70 meters deep with the help of a professional diver. Here you can see the prototype of the camera. This is the standalone version of the camera, which has no anti-fouling mechanism. So this one you will need to go regularly and clean eventually. And this is some of the images that we got from that camera. It was oh, maybe you don't see them much. Okay. It was supposed to be an artificial reef, but unfortunately there was very little life. But we produced a small time lapse where you can see some small creatures like sea stars moving around in this artificial structure. But other than that, there was very little fish to see. There was quite of a surprise for us. And we had this camera deployed for about 3 weeks in this location. So after that, we introduced another innovation in the camera. That's the current iteration of the camera, which is to replace the ultraviolet system in the exterior of the camera by a diode that it's inside of the camera housing. So as you see in this is the latest prototype. You can see there's an internal ultraviolet diode that it sits inside of the camera and it's pointing towards the flat glass. And what we had to do is to replace the standard material that is used in this type of camera housings, which is acrylic material, by a custom-made quartz glass, which is transparent to the frequencies of the UV diode. So in this picture, you see two prototypes, one that has the UV system and one that has not. And this has been deployed 3 weeks ago in one of the ANERIS observatories, in the OPSI observatory of UPC. So here you see two cameras packed before traveling to Barcelona for deployment. And here where the cameras were already mounted in a simple stainless steel frame to be attached into the observatory. And you see a blue cable. That's the daisy chain cable. So the cable that connects the two cameras, so that one camera provides power and data to the next camera in the series. So in theory, you can connect several cameras only using one connection point on the research infrastructure, which is a nice feature. So here are some pictures of the deployment where we work some days with the team at UPC at OPSI, and some videos of the cameras right after the deployment. This is the camera that has the ultraviolet system, and you see there are two also LED lights that we use during the night for short periods of time. And this is the other model, which is connected to the first camera, and this doesn't have any ultraviolet system. So we use this to compare. We want to compare the performance of the ultraviolet anti-fouling system. So this is some of the videos that we obtained right after the deployment of from the first camera, and you see there's quite a lot more interesting life in OPSI than in Oslofjord. And some, you can see some screen capture of a simple web interface that we have developed for to change the parameters of the cameras in a very simple manner. This is also in GitHub, so all the source code is publicly available. So this web interface can be used to control how often you turn on the lights, how often you turn on the ultraviolet anti-fouling mechanism, and things like this. So since the deployment at OPSI, we have created 2 YouTube channels, which are continuously streaming to YouTube. So if you go now to YouTube and search for ANERIS MUAS, OPSI, you will find these 2 channels with a live stream that we hope to keep this stream very long, but we'll see. Until we have some technical challenge, we will keep these streams live. At the same time, we are working on how to make this data available and how to integrate these observations into the pipeline of the operational marine biology data products. So one first step is to create a public repository. You can see the link here. And in these links, we are storing 1 picture every minute automatically from these 2 cameras. You can go and see if you go to this link. I think this presentation will make also public afterwards. So you can access the pictures, and of course the objective of the ANERIS project is that afterwards to implement some automatic algorithms that based on these images, we automatically generate some data products like detected species and with a timestamp and stuff like that. The 2 MOS cameras plus the already existing camera in the OPSI are also available all at the same time. If you go to OPSI website, just Google OPSI Live, you will get these 3 also live streams. And here you can see one of the pictures obtained from the first camera, and you can see a cable going through the. So from the second camera, you see cable going to the first camera. You see how are these cameras installed. During the night, we have actually a very not a very nice illumination. We used to quite cheap LEDs lights, and they are not very well placed. But we are testing this concept, and at the moment we are just turning the lights on for 1 minute every half an hour, and we're just using this to turn the lights, take a picture, and then turn the lights off. So we don't want to kind of modify the existing ecosystem. But it's interesting, and we've been seeing like when we turn the lights, usually there are fish around. So it's quite interesting. So here you can see a video of when the lights turn on. So this is night, and then you see the time here, 58, 59 seconds, and then lights turn on. You see also, if you notice here at the beginning, on the right part, this is the reflection of the ultraviolet system. So we actually can see also make sure that the system is working. Yeah. So yeah, and after 3 weeks already, we're seeing some biofouling on the camera that doesn't have the UV system. So this is only 3 weeks. And we got these pictures actually yesterday from the OPSI team at UPC. They make a dive, and they could see some growth on one of the cameras, but not growth in the UV camera. But of course, this is a test that we need to continue for much longer time. And yeah. And also on the image from the camera 2, which doesn't have the UV system, you already can begin to see some spots on the lens. So this is the biofouling. Yeah. What are we going to do in the future of the project? Of course, we need to test more the UV system. We need to improve also some design aspects to improve the heat dissipation of these diodes, so we can run them for longer time and test how much we need to have these duty cycles. We need to deploy also a similar system on Smart Bay in Ireland, which is also a similar cabled observatory that is part of the ANERIS project. Integration with other technologies and generation of the first OMB data products. Making some smarter algorithms to, instead of saving the images every minute, have more like motion detection or other types of logics to detect, to select these images. And of course, integrating this into the ANERIS general data platform. So with this, I think conclude the presentation. So thank you very much. And we're happy to answer some questions if there are some.